接下来请下一组上台。
Hello everyone, I'm Lin Zhongqian.
I'm Li Zhenghao.
Today we want to share our experiments about how water spheres, because the water always splash in the earth, but how is behavior in the space? To explore this, we designed the experiment. Throw the ball at the floating water sphere. Throw the ball in the water sphere and observe its behavior, whether it's broke apart or bouncing back.
During the experiment, we adjust the speed of the steel ball and and we carefully record how the water sphere changes shape and transfer energy. Through this observation, we can more carefully know how the collision works in wireless environment and space studies. Let's watch the video.
In this session, we will introduce the tools and items we used for our experiment. First, we use a number 14 plastic siren with a capacity of 30 ml. Next, we had a number 14 aluminum ball. We also use a number 34 ruler. Finally, we prepared 300 ml of water. Single experiment steps. First, we use a siren to draw 30 ml of water. These steps take approximately half minutes. Next, we carefully release the 30 ml of water to form a floating water droplet. These steps also required half minutes. Then we position one end of the ruler approximately 20 cm away from the water droplet. These steps ensures the proper alignment for the experiment. These steps take about 1 minute. After positioning the ruler, we place the steel ball at the designated marking on the ruler. For example, at 31 cm or 10 cm. This step is completed within the same 1 minute time frames as the ruler adjustment. Finally, within 1 second, we push the steel ball from its initial position on the ruler towards the water droplet. This action propels the ball to collide with the droplet. The total time required to complete all the steps is approximately 2 minutes. Repeat the experiment. The first set used a speed of 0.31 meters per second, with each experiment taking 2 minutes, total 4 minutes. The second set reduced the speed to 0.1 meters per second, also taking 2 minutes per experiment, total 4 minutes.
In our experiment, we expect two outcomes based on the speed of the steel ball. At the speed of 0.31 ms, the water droplet must burst due to the higher kinetic energy of the steel ball. At the speed of 0.1 ms, the water droplet is unlikely to burst, as the kinetic energy is below the critical threshold. For 30 G water droplet, we calculated the critical energy E critical using this formula, which is surface tension. This represents the minimum energy required to significantly disturb or break apart the water droplet. The kinetic energy of the steel ball is given by Ek. Therefore, if Ek is smaller than E critical, the steel ball will not break the water droplet. On the other hand, if Ek bigger than E critical, the water droplet will break apart. Let's talk about the conclusion. Why we choose this topic? To explore energy conservation in electric collision, which is challenging to achieve perfectly. To study how water forms a spherical shape due to surface tension, a phenomenon difficult to observe under gravity. These two unique challenges in zero gravity make us choose this topic. This is the end of our presentation. Thanks for listening.